In this video, we will explore how to perform the Mann-Whitney U test, which is a non-parametric test since it does not make assumptions about the distribution of the population data. It is sometimes also referred to as the Wilcoxon rank sum test because both tests yield the same p-value and lead to the same conclusions regarding the null hypothesis. This test is particularly useful for comparing two independent sample datasets when the normality assumption for the t-test is not met. Also, it works with both ordinal and continuous data, including scenarios with smaller sample sizes. Now, to conduct a Mann-Whitney U test, we will walk through a 5-step hypothesis testing procedure using a hypothetical scenario. Let's consider a university implemented a new interactive online learning module to enhance student engagement in a foundational statistics course. To assess its effectiveness, a pilot study was conducted. 2 independent groups of students were randomly selected. One group used the new online module as a supplementary resource, while the control group used traditional textbook readings and lectures. At the end of the semester, student engagement was measured on an ordinal scale, with scores ranging from 1 to 15, where higher scores indicated greater engagement. Now, let's begin the hypothesis test by formulating the null and alternative hypotheses. A null hypothesis, which is generally defined as the statement of no change or difference, states that there is no difference in the student engagement scores between students who used the new online learning module and those who followed a traditional learning approach. Conversely, the alternative hypothesis, which is defined as the statement of a significant difference, states that a significant difference exists in the student engagement scores between the two groups. While the Mann-Whitney U test does not assume normality, a few key assumptions regarding data type and sample collection must be satisfied, such as the two samples must be independent of each other, the collected data should be at least ordinal. In case of continuous data, the same is converted into ranks, and the samples within each group must be representative of their respective populations. In this scenario, students were assigned to each group randomly, the data values were measured on an ordinal scale, and the samples can be assumed to be representative of their respective populations. Therefore, we can proceed with the calculation of the test statistic. To calculate the test statistic, first, sort all the data values from smallest to largest. Rank them from 1 to n, where n is the total number of observations. If there are ties, assign them the average of the ranks they would have occupied. Now, sum the ranks for each group, then, calculate the U statistics for each group using the following formula, where n1 and n2 are the sample sizes of the traditional and module group, respectively. The U statistics for traditional and module groups are 34 and 2, respectively. To verify that the calculations are correct, the sum of U1 and U2 should be equal to the product of their respective sample sizes. Now, the Mann-Whitney U statistic is the smaller of the two values, U1 and U2. In this case, the U statistic is 2. After obtaining the test statistic, we will determine its critical value for a specific level of significance. For smaller sample sizes, the critical value can be obtained from the Mann-Whitney U table. However, if the sample size exceeds 20, the distribution of the U statistic can be approximated to a normal distribution. In the case of a large sample size, you would calculate the Z statistic using the following formula and compare it with the Z critical value for a specific level of significance to make a decision about the null hypothesis. Now, coming back to our scenario, the sample size of each group is small, therefore, we will refer to the U table for a two-tailed significance level of 0.05. The U critical value lies at the intersection of the row and column corresponding to the sample sizes of 6. The corresponding critical value is 5. Since the calculated U statistic is less than or equal to the critical value, we reject the null hypothesis. Therefore, at a 5% significance level, there is sufficient evidence to conclude that the difference in student engagement scores between students who use the new online learning module and those who followed a traditional learning approach is statistically significant. If you'd like to test your knowledge on this topic, Be sure to check the quiz link in the description below or visit our community page.